My name is Bram. I sometimes vlog, I sometimes tweet. I want to talk to you today about secure coding on the beam. So the talk title, off beam, it means on the wrong track. So of course, secure coding is it's not supposed to lead you on the wrong track, but rather on the right track. So maybe the talk should have been not off beam. Anyway, I'm sure you're all here because you have chosen or would like to choose the beam for your to build your products. It's a platform that's especially suitable for building robust systems that deal with failures. So I'm sure you're familiar with Joe Armstrong's dissertation. It's called Making Reliable Distributed Systems in the Presence of Software Errors. So supervision, for example, helps you recover from software errors without affecting the overall stability of your application. But software errors can lead to other issues. And in particular, software issues can turn out to be weaknesses. And weaknesses can lead to vulnerabilities in the presence of malicious users that they might exploit software bugs for compromising your application. So no amount of supervision trees can prevent that. Well, what a Beam application needs, like any other application, is a secure software development lifecycle. That's a process that you implement that basically aims to produce more secure software. And so secure coding is one of the elements in a secure software development lifecycle. Other stages, other activities include threat modeling, static analysis, dynamic security scanning, penetration testing, vulnerability of third-party software tracking. I hope you all went to Johanna's talk just now about HexDiff. So these are all different activities. They take place at different stages in the software development lifecycle. Some of them are good at catching certain issues, but not good at catching other issues. Having multiple stages in place provides some redundancy, so if something doesn't get caught early on, maybe you'll catch it later. And the nice thing about secure coding, which is what I'll be talking about now, is that it catches things really early on. It basically prevents its vulnerability from being introduced, or a weakness from being introduced early on in the process while it's still cheap to fix. Okay, so imagine if you introduce a bug and it turns out that this actually leads to a vulnerability. If you only find that during penetration testing on your staging system, or maybe even in your production system, imagine the potential cost. So if your system was exploited, that can be extremely costly. But even if that didn't happen, still, it can be very disruptive to your release cycle if you have to now go back and introduce a patch and or put a release on hold because of some potential vulnerability. So secure coding happens in the editor. You are typing away in your editor, and it's basically supposed to be the muscle memory of the programmer. You type something, you think, wait, am I doing this right? And maybe 9 times out of 10 you're doing it right, and there's no need to change what you're doing. But if the 1 time out of 10 that actually you were about to introduce a weakness, maybe you do a little Googling, you figure out what is the better way to do it, and then you've prevented a costly vulnerability or just a software bug in general. So, and it's okay to spend the extra couple of seconds, minutes, whatever it takes to basically double check what you're doing if 1 time out of 10 you actually prevent something much worse. So often it takes the form of a don't do this, but do that instead. So in the simplest form, that's what it is. So just as an example, let's have a look at other programming language. So in C, for example, of course, in C you do manual memory management, you work with pointers, and this can lead to very dangerous vulnerabilities around, for example, buffer overflows. So in C, it's probably it's safe to say you shouldn't use strcpy, string copy. You should use strncpy, which takes an additional argument, which specifies the size of the target buffer and avoids buffer overflows. And if nothing else, it just causes it basically lets the developer think about buffer overflows, because they have to pass in an additional parameter. maybe the compiler can automatically at runtime using a macro fill it in for you, but you still have to think about it. And just that step alone is probably going to prevent accidental buffer overflows. So another example, maybe a little closer to home to some of you, is in JavaScript, client-side JavaScript, when you're doing document object model manipulation. It seems to be like the default for updating the DOM is to set inner HTML. But there are cases, like inner HTML makes certain assumptions about the input that you're providing. Is that basically you sanitize the input, you know what you're doing. And if you're just updating text, so set inner text. Inner text is not susceptible to cross-site scripting the way inner HTML is. Now, if I write here, don't use inner HTML, but use inner text instead. So of course, it's not black and white. Like I said before, there are cases where you want to set inner HTML. But when you do, you need to be aware of what you're doing. Okay, so the rule is just a baseline, and you can deviate from the rule as long as you are sure that you know what you're doing. So on the beam, an example might be don't use list to atom, use list to existing atom. And we'll talk about atom exhaustion in a minute, but basically this is an example of what you might see as a suggestion on the beam. Now, until now, there wasn't really a document that describes secure coding guidelines for beam languages. Until now, because as part of the EEF security working group, we've been working on collecting some best practices around secure coding on the beam. And we've prepared a document. It's called the Secure Coding and Deployment Hardening Guidelines. And we've published a first public draft. And we're welcome to, we're ready to receive your feedback, suggestions, corrections. Again, it's not written in stone. It's not, some things you could argue, maybe this is good, it's not good, it is safe, it's not safe. But, it's a start. It's if you're aware of the issues that are described in the document, I think it will help you as you are coding to, recognize a potential issue as you are coding. Okay, the page linked here, that's where the document is hosted. You can submit issues or pull requests through our GitHub repo. And today I want to look at some parts of the document. I won't have time to go into the entire, cover all the topics. But basically the document covers 12 topics: atom exhaustion, serialization and deserialization, spawning external executables, protecting sensitive data, sandboxing untrusted code. I'm not going to talk about this, but basically the bottom line is don't. Preventing timing attacks. And then there's a couple of sections on some of the standard library applications, and one on a topic that's specific to Elixir, which I will also talk about in a minute. Okay, we don't cover third-party libraries. We don't talk about web topics, cross-site scripting and such. We don't talk about databases. These maybe we'll publish similar documents in the future about those topics. But this is really just about the Erlang language and standard library, plus other like Elixir and maybe other languages in the future. Why did the screen just go blank? Okay, so atom exhaustion. I already mentioned it briefly. The two atom functions are dangerous because if the atom table is of limited size, if you create atoms dynamically, you risk running out of atom table entries, and that will blow up your VM. And of course, that's if you're generating atoms from user provided input, those users could crash your VM. That's a denial of service vulnerability. And in Elixir, there are a few other functions that you should be careful with because interpolation can also create atoms. But what's perhaps more important is you should also keep an eye out for third-party libraries that might create atoms. For example, if you're parsing XML or JSON, some of those libraries, they return the data structures atomized because of convenience. It's perceived more convenient to work with. But if the input JSON or XML is coming from an external source that you do not fully trust, then this is a denial of service risk. Now, beyond denial of service, serialization and deserialization is a bit more risky because it can lead even to code execution vulnerabilities. So you may be tempted to use the external term format of Erlang. This is basically what you get if you call term to binary as a way of exchanging data with another Erlang VM, or maybe even with yourself through a database or through a cookie. And this is more efficient than encoding it using JSON or some other format, but ETF is very powerful. It can encode basically anything that you can represent as an Erlang term. And there's, for example, you probably don't have a need to serialize an anonymous function, do you? But ETF can serialize an anonymous function and deserialize it, and that would be, of course, very risky. So basically, stick to JSON, XML, protobuf, or whatever if you're interacting with an untrusted element or over an untrusted channel. Okay, you can use ETF if you must, but you have to make sure that you protect the integrity of that channel, maybe using a signature. And by the way, the term to binary function takes an optional argument called safe. That doesn't make it safe from, in the sense of preventing deserialization of anonymous functions. It basically just means that it doesn't convert atoms to, it basically does what the two existing atom functions do. Now, of course, deserializing an anonymous function is only a risk if you are then going to invoke that function, right? Now, you may say, okay, I'm not going to invoke any of the data structures that I deserialized, but in Elixir in particular, you can have some surprising cases of code invocation, code execution. So here's a little example, maybe contrived example, but a real example. So this website basically lets the user customize the theme of the website, maybe set a dark background or change the font or whatever. And it does so by setting a cookie called themes, and it basically serializes some Erlang terms into that cookie. When the next request comes in, it gets deserialized, and it then basically enumerates over that list in order to build the CSS that will be rendered to the user. Okay, it's a bit silly, I know, but it's just to show off that if an attacker, instead of sending a list of theme names or theme whatever is normally serialized, if they put this anonymous function in that cookie, the server executes this. And because an anonymous function with arity of 2 is basically implements the enumerable protocol, this function gets executed. Okay, the enumerable protocol, the stream implementation in Elixir uses enumerable under the hood, and it relies on the fact that anonymous functions with arity of 2 can basically produce data on each invocation. So this is a remote code execution vulnerability. Of course, the attacker could do something much worse than printing boom to the terminal. And there are other examples of the enumerable protocol basically leading to potential deserialization risks. For example, in this case, serializing a range, it basically produces a very small amount of data, but when this gets sent to this server, it basically starts to iterate over this endless range and calling this to, what's the name of the function? Theme to CSS, which again is a denial of service vulnerability because it's probably going to lock up a scheduler for you. Okay, so if you're working in Elixir and you want to prevent this, so there is a function in the plug crypto library that does a safer version of binary to term, which does not allow deserialization of functions. But it also needs to be past this safe option to prevent atoms from being created. But most of the time, don't use ETF. Like ETF is something for internal use. Don't use it in this kind of use cases. By the way, there's a version of plug coming out that allows you to sign arbitrary headers, and then what you could do is do what this website does and actually sign the cookie, and then you'll be able to validate the integrity. But still, I would say use another format. Okay, changing gears a little bit. Sometimes you may have a need to spawn an external executable. Okay, maybe you want to run OpenSSL to generate a certificate, or you want to use ImageMagick to convert an image file. And that's a risk, especially if you pass in arguments that were taken from user input, you might introduce a command injection vulnerability. So, if you're using Erlang, be very careful that OS CMD it's very difficult to prevent command injection. Instead, you should use OpenPort. OpenPort comes in two flavors. There's the flavor that spawns a command, the same way OSCMD does. But there's also spawn executable. And the difference is crucial here. The difference is the first two, OSCMD and OpenPort with spawn, will basically spawn a shell and pass the whole command to the shell. And the shell will then interpret that command to see which is the executable, where are the arguments. And the shell can do all sorts of interpolations on or other processing of that command. And it's very difficult, again, in code to detect these kind of injection attacks. And spawn executable does exactly what it says on the box. It spawns the specific executable, it bypasses the shell, and passes the arguments, the specific list of arguments that you set as an argument to this function, into that executable. So that neutralizes almost all command execution possibilities. Now, of course, it also means if you're using spawn executable, don't be tempted to use the shell as your executable and then, again, pass in a string of arguments, which is sometimes people do that because they want pipes, for example. But please don't do that, because then you're basically going back to square one. So let's look at an example. Here's a website that lets you add a caption to an image. And I'm basically concatenating all the arguments into a string and passing it to OSCMD. Now, if the user enters an environment variable like this, this will render the value of my environment variable on the image. Okay, and of course, the user can, or the attacker can do much more dangerous things. For example, run a command, which cat? Well, we saw a cat, which cat? This cat, /bin/cat. Okay, now there's good news for Elixir users. Previously, I was telling them that they should be extra careful. In this case, Elixir actually does the right thing. So the system CMD, it wraps OpenPort with spawn executable. So it gives you the protections that spawn executable gives you against command injection, but it also offers the convenience of OSCMD in that it returns the output of the command as a string. You don't have to, like in Erlang, if you replace OSCMD with OpenPort, you then have to figure out how to get the input from the port by receiving messages. So Elixir basically handles that for you. It also locates the executable in the path if necessary. But again, the warning: do not use a shell as the command, because then you're going to be vulnerable to command injection again. Now, one last thing on this topic is no matter what method you use to spawn a command, when you spawn a command, the environment of your application is copied into your child process. I'm talking operating system process. And so if you use environment variables to pass credentials, for example, database credentials, as I showed you in an earlier slide, those environment variables will be available in the child process. And okay, hopefully by protecting against command injection, those environment variables cannot be accessed by the user, right? But still, I would feel a bit nervous about that. This child process, it has no business knowing my database password. And this is something to keep in mind when you're reasoning about potential weaknesses in your application. Every single weakness in your application might seem kind of trivial and low risk, but a weakness, like a vulnerability, often is a combination of weaknesses that by themselves seem very low risk. But the trick of the attacker, of course, is to combine them in a smart way that actually they can compromise your application. So if you see an opportunity for just reducing the risk, so take it. In this case, clear environment variables. You can do that in Elixir by setting the environment variable to nil. In Erlang, you have to set it to false. And that will make sure that these environment variables are not exposed to your child process. So if the child process crashes, for example, it won't end up in a core dump. Or who knows what else might happen that causes it to leak. Okay, so since we're on the topic of leaking, protecting sensitive data. So, we're processing, maybe we're in our application, we collect passwords during log sign-in, maybe we have private keys for cryptographically signing messages. We have database credentials, maybe personal information from end users, and we want to minimize the risk of this data leaking our application. So how does data leak? Well, it might end up in a log accidentally because you're maybe inspecting some structure that has the sensitive data inside, or maybe as part of an exception. Some error happens, let it crash, exception gets logged, the log gets ingested by some, monitoring system that sends a message to a pager that maybe can be browsed by support staff, and if certain types of data just shouldn't end up in those logs. So it's made a bit more complicated in the Beam because of the immutability of data. So in other platforms, you might overwrite a key after you've used it, just zero it out. You can't do that on the Beam. We also can't really force data being released because of the garbage collection. I talked about logging an exception, and there's also crash dumps. So crash dumps are very useful for analyzing a failure or a crash, but they can also contain sensitive data. So, and there's introspection. Maybe you don't trust all your users because some of your users are maybe call center personnel that shouldn't have access to very sensitive data, but if they have access to, for example, Observer, they might introspect process state and see sensitive data in there. So there are techniques you could use to minimize the data leakage. Two of them I will talk about in more detail. One of them, passing closures to wrap the secret, and one is purging stack traces, purging arguments from stack traces. A few others are private at tables, the format status callback of the gen server, gen event, and gen statum behaviors. So that lets you filter or mask certain data in your process state. But I want to talk about wrapping secrets in particular. So here's an example. I'm going to sign a message, or basically create an HMAC signature over a message, and I need a key for that. So I need to keep the key in my application state somewhere. I need to pass it around maybe, and I don't want it to leak in an exception. So what I can do is I can wrap it in an anonymous function. And as you can see, when that anonymous function gets inspected, you don't see the secret value, you just see fun. But at some point, you're going to have to pass that secret into a function that is going to do something with it, right? So if I now call the crypto API to calculate my HMAC, and I pass in my unwrapped secret, I'm invoking the anonymous function here to basically pass the secret to crypto. If in some code path my message is not set, it's set to undefined, that's an invalid value for the crypto API. It will crash, and you see my secret gets dumped into the logs. Now, there's a way to prevent this, and that is by purging the arguments from the stack trace. If you've used Erlang for a while, you probably remember that until not so long ago, arguments were not shown in stack traces at all. The stack traces would only show the arity of functions. And it's possible to go back to that old behavior by writing a little wrapper around your call to a function that doesn't support wrapped keys or wrapped secrets. So in this case, we're calling the crypto API. If an exception happens, I'm pruning the stack trace. So this is how the stack trace pruning looks like. Basically, if the first element in the list has a list of arguments, it replaces the list of arguments with the arity of the function, the length of the list. And then it re-raises the exception. So now, if I, again, wrap my key, I call this function, the pruned function. I don't have to unwrap the key here. I pass the wrapped key, the anonymous function, into this function. If an exception happens, I still get my stack trace, which is useful for debugging, but I don't get the arguments, and therefore I don't get the secret. Now, of course, you could say maybe I could write an exception handler that will detect this particular case and mask only the secret, and then I will still have the arguments for the other, the values for the other arguments, like the undefined, because I lose that visibility. But the moment you start to be smart about this, you'll probably miss some cases, and some exception occurs maybe a little deeper down, and the secret still gets leaked into the logs. So I would stick to a simple implementation like the one I showed you. And in the document, the secure coding guidelines document that you can find online, you'll see also an Elixir version of this this technique. So these two, as I showed you, these two techniques can be combined to allow in your own functions to allow the caller to pass in a closure instead of a secret as a binary, and then prune the stack trace in the function that unwraps it when you have to pass the function into an API that doesn't support wrapped secrets. Now, this technique is used in the stack trace pruning is used in the plug crypto package. That's where I stole it from, and you can use it yourself. You can use this function. It's a public documented function. You can use it in your own applications. Now, I want to briefly mention the SSL application. I've done a talk about it in other places, but the most important thing you have to remember when using the SSL API is when you're implementing a client or using a client that under the hood uses SSL, pass verify peer, because by default, the SSL client does not verify the server certificate. Okay, again, I don't have time to go into it now. There's a whole chapter in the document about all the various SSL configuration options that you should use. Another thing is you need to pass a CA trust store. Remember, you can use the operating system to CA trust store. If you know that you're going to deploy on a certain version and certain distribution of Linux, you know where the trust store lives. You can just pass that path. Using a hex package for a CA trust store, it's an option. You can do that, but it just means that you have to basically update your application in order to update the CA trust store, which seems a bit odd to me that you would have to release a new version of your application to revoke maybe a CA that was compromised. I would rather just go to the operating system, run the operating system's package updates every now and then, and that should update the operating system trust store, and my application should just pick it up from there. Again, I did a talk, you can probably find it online somewhere. Learn you some SSL for much security. Apologies to Fred for that. But xmerl, I want to mention quickly. So xmerl scan creates atoms from tags and attribute names. So even some of the applications, like the more popular libraries around it, use XMRL scan under the hood. And like I said before, if you process data from an untrusted source, this can lead to denial of service. So please be careful. The XMRL SAX parser does the right thing. It doesn't produce atoms, but it is vulnerable to the billion laughs attack. So billion laughs attack is basically entity expansion, and it can basically lock up a scheduler with some small bit of XML, and it's possible to prevent that by raising an exception from certain callbacks that you need to implement to use this API. Again, it's all in the document, so be careful. Now, I want to talk about one topic that's specific to Elixir, and that is Boolean coercion. So, unlike Erlang, Elixir has this notion of a truthy value. A truthy value is anything that's not nil or false. Now, Erlang doesn't have a nil notion of nil at all. It does sometimes return undefined, but undefined, at least Elixir would consider that truthy. It's not nil, it's not false, so that's truthy, right? So this can actually lead to subtle bugs that can then lead to weaknesses, which can lead to vulnerabilities. And it's used in branching and in Boolean algebra. So if, unless, and cond all assume that their argument is a truthy argument. Now let's look at how things can go wrong with this. So here's an example. We are calling some Erlang library that returns OK or error with a reason. And I'm calling the signature verification function, and then I'm using the two vertical bars or raise an exception. Now, of course, this is always going to succeed, right? None of the possible return values of this verify function is false. It's falsy. It's never nil. It's never false. So I never get an exception. Basically, any signature is considered valid. Now, of course, hopefully this bug you will find in testing, or maybe Dialyzer will flag it for you. But again, secure coding is just one of the activities in a secure software development lifecycle. You want redundancy, so I would argue don't even do this. Make this more explicit. You expect a Boolean value, so use or, the keyword or, because this will fail if the first argument is not a Boolean. And therefore, you will find these issues early on. And even if you miss it in your testing, I see a lot of times people in their tests, they only test the happy path. And when it comes to security, things like talking to an HTTPS server, and it succeeds because the server presented the correct certificate. Okay, that's cool, it succeeded, but does it fail when the certificate is expired? Does it fail when the certificate has been revoked? Does it fail when the server presents a self-signed certificate? Test all the negative cases. Same thing here. If you don't test this signature verification, the negative path where false signature is being passed in, then you don't have proper test coverage. But again, in secure coding, that happens way before all this testing. So I would say use or actually what I would do is I would be explicit about it. I would just use a case statement and then explicitly match on true and false. This is also clearer to the reader. And I think the use of the vertical bars as or, it comes from, it's mostly seen in Ruby programmers, because in Ruby you use this version because of precedence rules, I think. The or keyword has a weird precedence and things get mixed up. But so please be aware that the or keyword is actually safer. Okay, wrapping up, we have a chapter on deployment hardening in the guide. It's not quite finished yet. I don't have time to talk about it, but it's there. Please have a look. It covers topics like how to install or build the runtime system, releases, why you might want to use them, how to use them, distribution. For example, how do you make sure that the distribution protocol listens on the network interface that you want it to listen, instead of binding to all network interfaces, including front-end facing interfaces, and crash dumps and core dumps. And we might add more. For example, I want to cover configuration management. How do you pass secrets into your application, such as those database credentials? A few more. Another chapter in the document is lists some tools and resources. So Dialyzer, Credo, and so below are static analysis tools that can help. Again, if you missed something in your secure coding, you actually type something that you shouldn't have typed. So one of these tools might be able to flag it for you. And in terms of documentation, in general, I think OWASP is a great resource. It's mostly focused on web type applications, but it covers also a few more lower level issues around secure coding. And for the deployment hardening, the CIS benchmarks, I saw the previous speaker mentioned it as well for Kubernetes. So this covers things like the operating system, the database, your container platform, the cloud. Okay, so again, we've published the first draft of the document. We welcome feedback, suggestions. Please have a look. Let us know if you like it. You don't have to agree with everything. Mostly it's about awareness. If you are aware of it and if you know you're doing the right thing, go ahead, go for it. Later today there'll be an update from the EEF, what all the working groups have been up to, so I'll tell you a few more words about what we've been doing in the security working group as well. So that's the last talk today in this room. Tomorrow Peter will give the OTP updates, but that's not really security related, but Duncan will be talking about securing IoT. So that's the first talk in the morning, I believe, or the first one after Peter's OTP update. So that's other members of the security working group giving talks tomorrow. I want to thank my employer, Blue Code, who has let me work on the EEF security working group and open source contributions and allowed me to come here and talk to you. And that's it. I'm sometimes blog, I sometimes tweet, and thank you for coming.
Okay, any question? No questions? Okay, thank you, Bram.
Thank you.